Hey, welcome back to another calculus lesson with Mr. Thompson. This time we're on section 4.5, finishing our work with trigonometric functions, this time looking at the derivatives of the inverse trigonometric functions. Now, first thing I want to do real quick is just to point out something that I don't want you to do. Now, sine squared x is the same thing as sine x squared. Sine negative 1 x is not the same thing as sine x to the negative 1. Okay, big difference. I hate the fact that we do have this discrepancy. I went over that in class, but we do have it, so just make sure you cannot do that. Okay, so just don't. Inverse of sine is cosecant x, the sine x to the negative 1 is the cosecant x, not inverse sine x. They are not the inverses of each other. Alright, so just be careful, don't make that mistake once we start getting into the inverse trig functions. Now, that being said, the inverse trig functions are sine negative 1x, cosine negative 1x, tangent negative 1x, cotangent negative 1x, and so on. Let me write down the other two. Secant negative 1x, and cosecant negative 1x. So those are our inverse functions. They each have their own issues as far as domain. You can't plug in certain numbers into them, stuff along those lines, which I talked about in class as well. Mostly it restricts the inverse sine, inverse cosine. Inverse tangent and inverse cotangent, you can plug in almost anything you want. But inverse cosecant and inverse secant, almost, okay, but not quite. Not really going to talk about that right now. That's just more of the background. Let's go ahead and look at what these equal. Okay, so I'm looking at the table on page 151, which gives us basically a cheat sheet for the derivative of each of these. So sine negative 1x is 1 over square roots 1 minus x squared. That's the derivative of the inverse sine x. Inverse cosine, as you might guess, it's a negative 1, and then pretty much the same thing, 1 minus x squared. Inverse tangent is almost the same thing, except for no square root on the bottom, and it's 1 plus x squared. Cotangent, negative 1. Inverse cotangent, x is same thing, but negative 1, 1 plus x squared. Inverse secant, it starts getting a little different. 1 over absolute value x times square roots x squared minus 1. And then inverse cosecant, almost the same thing, but negative on the top. So once again, when you have a co on the trigonometric function, the derivative is going to wind up with negative, whether it's regular or inverse. So those are our inverse trig functions and their derivatives. Once again, we can show where they come from, but the more important thing is have the list, know how to use them, know that they exist. Let's go ahead and look at one of the examples just to show you how it will apply in the problem. So simple example number 13. Our function is y equals inverse sine of 4x. So let's get an idea of where the 4 comes into play with this. First of all, this is not product rule, chain rule, nothing along those lines. It's simply derivative of the function. The 4 winds up on top. So I have 4 on the bottom is square roots 1 minus, and then here's the tricky part. It's the derivative of the inside squared, so 16 x squared. So tricky part, don't forget that on the bottom, but that's just our derivative right there. Derivative of the inside goes on top and then gets squared in front of the x squared. Works pretty much the same way for all the other functions. Just Just make sure you don't lose the derivative of the inside as you're taking the derivative of the whole function. So once again, just another list of tricks for you to have to find the derivative of pretty much any function you need to.